Hi guys, and welcome back. So today we are going to be solving equations that have logs in them, or equations with a logarithm. And if you want to impress your friends, then you tell them that today we are going to be solving logarithmic equations. Some logarithmic equations have only one log. Some of them may have more than one log. Today we will focus our energy on solving equations that have more than one log. The question is, how are we going to handle this? From an earlier video, we had said this. So if we have log base b of x equals y. So a gentle reminder, a log is just an exponent, okay? So from back in the day, probably like yesterday, we had said log base b of x equals y means b to the y equals x. Okay, so the question is, should we memorize this? Should we memorize that, oh, log base b of x equals y means b to the y equals x, and vice versa, that b to the y equals x means log base b of x? I don't know if I said that correctly, but pretend I did. No. Okay, technically yes, but we don't have to remember it like that. For me, it's just so much easier if I write it in words. Okay, so now, how do we solve a logarithmic equation? Since we only have one log, what we're going to do right now is write it in exponential form. So let me go ahead and speak to myself. Write in exponential form. Okay, so how are we going to do that? Again, you have options. Option 1, memorize. Log base b of x equals y means b to the y equals x, or just speak to yourself, okay? So remember, a logarithm is just an exponent. So let's speak to ourselves. To get out of the log, or to write it in exponential form, we're going to take the base, raise it to some power, and that will give us the argument. So remember, argument is just code for whatever you're taking the logarithm of. So let's go ahead, get this out of the log, or put it in exponential form. So how are we going to do that? We're going to take the base. So the base of the log is 3. Okay, so we have 3 to some power. And I'm like, oh man, where's the power? Where's the exponent? Remember, a log is just an exponent. So if the log equals -3, then check it out. The exponent is -3. Okay, so base to some power equals the argument. What is the argument? Argument is just code for whatever you're taking the logarithm of. So in this case, the argument is x. That is the answer. Okay, we are asked to solve, solve for x. X is isolated. But in this case, we have to keep moving forward because we can simplify or evaluate 3 to the -3rd power. So you can freehand it or punch it in. I lost my calculator, so I'm going to have to freehand it. So then I'm like, okay, well, how am I going to simplify this? I really don't know how to evaluate 3 to the -3rd in my head. Why? Because that negative exponent is messing with my flow. So we're going to go ahead, bust out the negative exponent rule. So from back in the day, we have said this. If we have a factor and we are raising it to a negative power, how are we going to fix it? How are we going to make the exponent positive? To make the exponent positive, you're going to move the factor to the other side of the fraction bar. And if there's not a fraction bar, make one up. And then with confidence, we're like, oh yeah, move this bad boy to the other side. So we're going to move the factor of x to the other side of the fraction bar. We're going to switch out the sign on the exponent. Before we were negative, now we came to the other side. So let's switch out the exponent to make it positive. And then we just have a 1 in the numerator. Oh, I don't know why I was going to box this like if it was my answer. I'm not nervous, you're nervous, okay? Yeah, I don't have whiteout. I'm just going to have to live with that thing. Cool. All right. So let's go ahead, rewrite this. So the 3 is being raised to a positive exponent, and then we'll have a fighting chance to simplify it by hand. Okay, so there's no fraction bar, so let's go ahead and make one up. And then with confidence, to make the exponent positive, we apply the negative exponent rule. How? By moving the factor to the other side of the fraction bar. So here's our fraction bar. We move the factor of 3 and we switch out the exponent. It's going to look a little bit weird if we leave it as blank over 3 cubed. So we're going to go ahead and put a 1 in its place. Okay, so that is still the answer, but we're trying to generally evaluate it by hand. Last time I checked, 3 to the third power is 27. So the moral of the story is that the value of x is 1/27. You know, if you wanted to check it by hand, then you punch it in your calculator. You know, log base 3 of x, log base 3 of 1/27. When you hit the equal sign, that should give you -3. But I checked it at my house, so we're good. Okay, so we're doing 3 problems. Let's go ahead and knock out the next one. So problem B, just give me a sec. So for problem B, we have log base 1/3 of 2x plus 5 is equal to 2. Sorry, is equal to 2. My accent gets in the way at times. Okay, so I'm like, okay, how am I going to solve this? I'm like, okay, we only have one log. Then to solve it, we're going to quickly write this in exponential form. So in English, you know, get out of the log. So I'm like, okay, how am I going to do it? To write it in exponential form, let's go ahead and do this. We're going to take the base, raise it to some power, and that will give us the argument. Okay, for me, to go from log form to exponential form, it's so much easier if I write it in words versus trying to memorize this. Like, this means nothing, okay? But when I write it in words, like, words are powerful. The words actually help me more, okay? So let's go ahead, go from logarithmic form to exponential form, or like in English, get out of the log. So the base, what is the base? The base of the logarithm is 1/3. So we're going to take that 1/3, and then we're going to raise it to some power. I'm like, where is that power? Just remember what a log is. A log is just an exponent. So if the log equals 2, then guess what? The exponent equals 2. Okay, so base raised to some power equals argument. Argument is 2x plus 5. And for me, I don't know about you, but once I get this in exponential form, or once I get it out of the log, it's like a, how do you say it, a breath of fresh air. It's like, a weight has been lifted off my shoulders. Okay, no more sayings. Let's stick to math. So let's keep our cool, simplify the left. The square of a third, 1/3 times 1/3 will give us 1/9. And that will give us 2x plus 5. Okay, so you have a couple of options. So option 1, you know, clear the fractions, or option 2, keep I don't know about you, but me and fractions don't get along. So with your permission, we're just gonna wipe out the fractions. Okay, there is only one denominator, so that one denominator is the LCD. Okay, if you're trying to wipe out the fractions, then go ahead and multiply both sides by the common denominator just found. So we're going to multiply, we're going to multiply the left side by 9. We're going to go ahead and multiply the right side by 9. When we do, the product of 9 and 1/9 will give us 1. And that will give us whatever the product of this sum and that sum gives us. So let's go ahead, take our time, and distribute. Product of 9 and 2x is 18x, and the product of 9 and 5 is 45. Okay, so we have a degree 1 equation, or a linear equation. So let's go ahead, old school it. Variables on one side, non-variables on the other. If I can read your mind, let's go ahead, subtract 45 from both sides. Why? Because subtraction, to undo an addition, we're going to go ahead and subtract. Okay, so we take our time, and after we subtract 45 from both sides, that will leave us with -44 is equal to 18x. Fantastic. To finish it off, to isolate the x, to get rid of the times 18, let's go ahead, divide both sides by 18. And when we do, that will give us any equivalent simplified form of x equals -44 over 18. Now, I know that this fraction is not reduced because the numerator and denominator have a common factor of at least 2. So let's go ahead, reduce by 2. You can use your cross-counting notation, but I like to old school reduce, because if I explicitly show what I reduce by, I don't have to worry later like, how did I get my answer? Okay. So when we reduce by 2, however you like, the numerator will give you -22 and the denominator will give you 9. Okay, you can put the negative at the top, bottom, or in the middle. Okay, that gives us x. 22 and 9 have no more factors in common other than 1, so we're good. Okay, for those of you that are big fans of the decimals, decimals are fine as long as you don't round. What's the decimal equivalent? So if you're gonna go straight to decimal form, then there's no need to reduce. Okay, because if you reduce wrong, then that's it. You can just go decimal form from this point. So we have 44 over 18, and that gives us 2.4 with the 4 repeats. Okay, but remember it's going to be negative. So x equals negative 2.4 with the 4 repeats. So if you're going to go the decimal route, your answer needs to be exact. Okay, so I promised you a total of 3 problems. Let me go ahead and hunt the third and final problem. Okay, so the third and final problem has been located. So our problem reads logarithm base x of 5 equals 4. So I'm like, okay, how are we going to handle it? Our first goal is to get out of the log or write it in exponential form. So to do that, we're going to take the base, raise it to some power, and that should give us the argument. Okay, so digest it however you can. Okay, the base, in this case, the base of the logarithm is x. So base to some power. So I'm like, oh, where's the power? Where's the exponent? Remember, a log is just an exponent. So if the log equals 4, then the exponent is 4. Okay, so log equals 4, exponent is 4. So base raised to some power gives us the argument. Argument is just code for what are you taking the log of. So in this case, we're taking the logarithm of 5. So the argument is 5. Okay. That's our equation. It's not a linear equation, but it's okay. We're not going to panic. The variable part is isolated. So now I'm like, okay, what are we going to do to undo the power of 4? If the exponent was 2, we're like, oh, square root both sides. If the exponent was 3, cube root of both sides. So pretty much to undo the power, we're going to take a radical. Okay, so to undo the power of 4, we're going to take not the square root, not the cube root, but we're going to take the 4th root. Okay, we're going to take the 4th root of both sides. So on the left side, index is 4, power is 4. They're the same, so they undo each other. And that will leave us with the radicand of 4 equals whatever the 4th root of 5 simplifies to. Last time I checked, the 4th root of 5 is already simplified, and that will be our answer. Okay guys, so that's my time, and then if you come back in the next video, we'll do a handful of more problems. Thanks.